Hello students. Today we are going to deal with the topic current electricity. As we know, it is a branch of physics where we study about the flow of charges in a regular direction. We know that current is formed due to the movement of charges. We know that current is formed due to the movement of charges. And I is equal to Q by T is the equation for finding current. We know that Q is the charge, T is the time, and I is the current. So for finding current, we have this equation I is equal to Q by T. Now we are going to discuss about drift velocity. We are going to discuss about drift velocity, and always drift velocity is denoted by Vd. For that, we are considering a conductor. Here we are considering a conductor of length L. So we know that a conductor consists of positive charges as well as negative charges. A conductor consists of positive charges as well as negative charges. Here, there is no electric field. Here there is no electric field. So the charges is in a random motion. Here there is no electric field. The charges in this conductor will be in a random motion. That means if this charge is moving towards this direction, the other charge will be on the opposite direction. So these charges will be in a random motion. So there is no net flow of charge. There is no net flow of, and we know that if there is no net flow of charge, there will be no current also. If there is no net flow of charge, then no current will form. No current will. So now we are going to connect an external cell to the conductor. Here is the cell. We connected our conductor to an external cell. So we know that there are two terminals for a cell. One is the positive terminal, the other one is the negative terminal. So here this one is the positive terminal and this one is the negative terminal of the cell. So when it is connected, the negative charges in the conductor will flow towards the positive terminal of the battery. So when the cell is connected, the negative charge in the conductor will flow towards the positive terminal of the cell. So as shown in the figure, the negative charges will align towards the positive terminal of the cell. But here we know that in between these negative charges, there are positive charges also. There are some positive charges also. While moving, the free electrons get collided with the positive charges. While moving, the electrons, the negative charge, will get collided with the positive charges in between them, and they acquire a zigzag motion. As they get collided, it changes its direction of motion and it acquires a zigzag motion in the conductor. So for moving, the negative electrons acquire a velocity here. For moving through the conductor, the electrons acquire a velocity to move towards the positive terminal, of the cell. But it was not in a straight line, it is a zigzag motion. So we can define drift velocity, that is drift velocity is the average velocity acquired by the electron inside the conductor when it is subjected to an electric field. The point is important. The drift velocity is the average velocity acquired by the electron inside the conductor when it is subjected to an electric field. Next topic is a relaxation time. So for that, we are again considering a conductor of length L. We are considering a conductor of length L. And we know that the conductor consists of positive and negative charges. A conductor consists of positive and negative charges. So we already studied that when the electrons are moving towards the positive terminal of the cell, there is a chance that the negative electrons get hit by the positive charges in between them. So consider this electron which is moving and it get collided with a positive charge here, and it changed the direction of movement and it collided with another positive charge in the conductor. So here, for the first collision, consider that for the first collision, the time taken by the electron is T1, and for the second collision, that is T2. Then we can say that here relaxation time tau is equal to T1 plus T2 by 2. That means the average time of the two collisions. Tau is equal to T1 plus T2 by 2. That means the average time of two collisions. So we can define relaxation time as the average time interval between two successive collisions. The average time interval between two successive collisions is known as relaxation time. So today we deal with two different topics. First one is drift velocity. We already studied that drift velocity is the average velocity acquired by the electron inside the conductor when it is subjected to an electric field. Drift velocity is the average velocity acquired by the electron inside the conductor when it is subjected to an electric field. The next topic was relaxation time. We denote relaxation time by the symbol tau. So relaxation time is the average time interval between two successive collisions. Relaxation time is the average time interval between two successive collisions.